Right, this is Algebra 1, or sorry, Geometry A, Unit 4, Lesson 2. We're going to look today at translations. Trans meaning across, so to translate means to move across. We think of it in terms of languages, to translate from one language to another, to translate or move the meaning from, say, Chinese to English, or vice versa. In geometry, it means to move. So let me introduce this on a coordinate grid. I'm going to put a point right here. You may recall coordinates here. This is the point 1, 2. We'll call this point A. And let's say we got another point right here. This is 2, 4, 6, 8, 9, 9, 3. Call this point B, 9, 3. Okay. And let's put point C right here. And we'll call this, let's see, 2, 4, 6, 7, 2, 4, 6, 8, 7, 8. Okay. And you can see clearly that we have a polygon with 3 vertices. Okay. In this case, the polygon, the particular type of polygon, is a triangle. It has 3 sides. Okay, but we can translate, we can slide this left, right, up, down. Okay, and one way I might do that here is to slide it to the left 3 units, or let's go left 5 units. Okay, so let me change colors here. I'm going to go left 5 units. I'm going to take point C, and I'm going to translate it 5 units left, and I'm going to follow this rule. I'm going to say 5 left and 8 down. 5 left and 8 down. Okay, so take point C and move 5 units to the left. 1, 2, 3, 4, 5. 5 units left. And 8 down. 8 down. So I'm going to go down 8 from there. Two, 4, 6, 8. Puts me right here. Okay, down 8. And so I will say C prime is right here. Now, C is called the pre-image, and C prime is called the image. Okay, C prime is called the image. And it was 5 to the left, so it goes negative 5, because left is negative. And 8 down, so it's negative 8. Okay. That results in something called a vector. A vector. And so if I move from C to C prime, I have moved along this diagonal to end up at C prime. And so this is the vector negative 5, comma, negative 8. Notice the way it works. It's not in parentheses, but it's in pointy brackets, so to speak. This indicates a vector of magnitude and direction. So it's 5 left and 8 down. And that describes the translation to C prime. We can apply this to the other points as well. B goes left 5, 1, 2, 3, 4, 5, and 8 down, 8, 1, 2, 3, 4, 5, 6, 7, 8. So this is V prime. Okay? And notice its vector, I'm just going to draw the diagonal component, has the same length and is going the same direction. And so this vector is parallel to the original. It's still indicated by the vector negative 5, negative 8. We went 5 left and 8 down. Okay? And we can apply this to A as well to find the image of A. I'm going to move 5 to the left. 1, 2, 3, 4, 5, and 8 down. 1, 2, 3, 4, 5, 6, 7, 8. Here's A prime, the image of A, and its vector, movement vector, is right here. Notice I can take the tool and just move it and paste it right on, and it matches. It's parallel and it's the same length. Okay. All right, and the resulting polygon, if we look at it here, is congruent to the original. It hasn't changed shape or size. And thus we call the translation a rigid transformation. Okay? The orange triangle is exactly the same shape and size and orientation. It hasn't been flipped or rotated or anything. Okay? And there we go. All right? So that's the nature of a translation. We use vectors to describe the translation, and we can use language to describe the translation. 5 left, 8 down, and this vector is equivalent to the 5 left, 8 down. Okay, let's try one more example here to see if we can help make sense. This time I'm going to go the other direction. I'm going to start with a description of a translation. Translate DEF by the vector, and I'm going to indicate the vector, -4, +3. Okay, let's translate that into words. In words, that would be equivalent to be saying left 4, because the first number tells me to go left or right, and up 3. Okay, and let's put a shape up here to start with here. How about D, E, F. Okay, triangle DEF. So draw the polygon. Okay, and we're going to translate it by the rule -4, 3. So let's go, how about red? Right? -4, 3. That means left 4. So I'm going to start from E. 1, 2, 3, 4, up 3. 1, 2, 3. There's E prime. D, left 4. 1, 2, 3, 4, up 3. 1, 2, 3. There's D prime. F prime, left 4, 1, 2, 3, 4, up 3, 1, 2, 3. F prime. Okay, so DEF is the image, free image, and D prime, E prime, F prime is the image. Okay, and you'll notice that all the sides of the triangle are parallel to the original sides of the triangle. And the triangle has moved to a new location, but it hasn't spun or changed size or shape or flipped. It hasn't flipped. Okay? Let me draw the vectors. And you'll note that the vectors are all parallel and the same length. E to E prime, F to F prime, D to D prime. Okay, and that's the movement vector. -4, +3. All of them have the same value because you can move vectors around. Vectors aren't stuck to a particular location. They just indicate length and direction. All right? So that's it. That's translations. Hopefully that helps.